Okay. All right. Today we will be starting on, well, a couple of things. We'll be doing simplifying radicals and we'll continue our algebra worksheet number 8. Thank you, Alva, for sending those answers in.
Okay, thank you, Ms. Barber.
Okay, we'll go over those.
Yes.
I think we'll probably look at the simplified radicals first. Did everybody get that multiple choice worksheet I sent?
You mean the quiz?
She sent another one.
No, simplifying radicals. It was 10 multiple choice questions, kind of reviewing what we went through on Thursday.
Yes, I got mine.
You got it? Well, we'll go through it. Okay. Alva, did you get this one? Simplifying radicals worksheet? Do you see it on the screen?
What number it start from?
Let
one?
me, it starts from 1.
Oh,
Okay. Does everybody see the simplifying radicals worksheet
I'll check my
on the
phone.
screen?
Yes, Miss Barbara.
Okay. Do you see it, Alva?
Yes, I'm seeing it, Ms. Barber.
Okay, simplifying radicals. Well, we did a lot of examples on Thursday and just want to go through these to see if you remember some of them. If not, we'll go over them, okay? Now, there's something we said about simplifying radicals. We said when the number was a prime number, that means you don't have any factors other than the number itself and 1. So that means it would be.
Excuse me, Ms. Barber, something is on the computer that need to come on. It's
Okay.
blocking the area of
Blocking the
light.
screen.
Yes.
You have to click continue because she's recording. If you said to leave, you're gonna come out of the session.
Okay, yes, it is off now.
Yeah.
All right.
Okay, Alva, do you see the screen?
Yes, I'm seeing it.
Simplifying radicals.
Yeah.
And what I was saying is that when it's a prime number, it can only be multiplied by itself and 1, which means you can't factor it into numbers other than itself and 1. Hello, Chastity. Chastity is on. Okay, so let's look
Hi,
at
good afternoon.
Hello, Chastity. Now, let's see if you remember the simplifying radicals. Alva, number 1, simplify 31, square root of 31. Now, can you think of any factors you can multiply and get 31? Alva?
Yes.
What are 2 numbers you can multiply and get 31?
Let me see now. It would be 15 and 16.
Factors, not something you add. Factors mean you multiply the 2 numbers and get.
To get 31.
Yes.
Okay.
Can you think of 2 numbers you can multiply? Factors are the numbers that you multiply to get the number.
Okay.
Can you think of 2 numbers you can multiply and get 31?
Get 31. No, I'm not thinking.
Other than 31 and 1. Well, you said 15. Well, 15 times 2 is 30. So we know those are not factors because 15 times 2 is not 31. It's 30. What about it, Vanessa? Any numbers?
None. There's none.
So what would be the answer for number 1?
It would be me.
D.
What would it be?
Yeah. D.
B, that's right. Already simplified. Because 31 is a prime number. So the only factors are 31 and 1. So you put answer
B as in boy.
B as in boy. That's correct. Answer B as in boy. Now, when we talked about simplifying, we said you had the radical sign and you had something under the radical sign. And what do we call that? Jess, do you remember?
Which one you're doing? 2?
Number 2.
Okay.
From the radical sign.
This is the radicals, the square root sign, right? The number under the radical here is 31. What do we call that number? Which one of these, Chastity? A, B, C, or D?
Hmm,
Remember?
I'm not sure. Is it a factor?
Is it B?
It is B. That's correct.
Radican.
Radican.
Okay.
Yeah. Remember I said the number that's under the radical sign, you only have two parts now. You have the
Yes.
radical, the square root, and then you have the number. That number is called the radicand. So that would be answer B. Okay. It's only two parts. The radical itself, which is the square root sign, or the number, which is the radicand.
Miss Barbara, you can hear me?
Yes, Maureen.
Okay.
You on earlier than you said. I got your text.
Yeah, oh yeah, because I was ready for the bus, so I think I'm gonna get home in time.
Oh, okay. All right, Maureen, just in time to do number 3. You're just
See
in
what?
time to do number 3. Simplify the following radical. Square root of 32. What two factors multiply to give you 32, Maureen?
Okay.
Two numbers you can multiply and get 32. And try to
Oh,
think
I
of
need
a
it.
number that has a perfect square root.
Oh, perfect square root, okay.
Yes. If
You
not, we
say
can break it
32?
down. You just tell me the numbers and we'll fix it, okay?
It's like two answers in there.
Chastity,
Is it?
you said there are two answers?
Oh, no, no, this one. I got it.
It says simplify. So you want to get the simplest version of the square root of 32. Maureen, you
this
want
is
to tell me, or Chastity, you want to tell me?
8 and 4.
There's
No,
B and C.
no, it's D.
Is D?
It's
Yes.
only one answer.
It's D.
And I said,
Okay.
remember
Yeah, you're
I told
right.
you to remember some of the perfect square roots,
It's 4 and 2.
right?
It's 4 and 8.
4 and 2.
Maureen, you said B.
Yeah.
Vanessa said D as in dog. Chastity,
I
what are
was
you saying?
I was thinking it was B.
Okay, you saying B. What are you saying, Maureen?
You say 32, right? Or 31?
No, we
32.
number 3.
Oh, number 3.
Yeah, square root of 32. This is
Oh, 4 and
number.
8 B. 4 and 8 B.
You said B?
Yeah.
Okay. How did you get B, Maureen?
I said 4 8 is 32, 8 4 is 32.
What are the factors of 32?
4 and 8.
What?
4.
I would say C.
You would say C.
Yeah.
I thought there was like two answers. I thought it was B and C for some reason.
Oh, you say 32.
Vanessa, what did you say?
D, because 4, 4 is 16. And 16 twos is 32.
So what factors are you using, Vanessa?
I'm using 4.
Okay, so you can take a radical and its number and
So it would
factor
be
it.
the answer
Use
the answer
16
is
and
Barbara would be
4.
C.
Okay, now Vanessa
Barbara
is
C?
factoring this. Tell me what you put, Vanessa. What's the factor here?
Okay, you put 16.
16. And
And
that's times what?
16 times 2.
That's right. See, Vanessa took her square root of 32 and factored it into two factors, which is square root of 16 times square root of 2. That gives you square root of 32. Then what did you do, Vanessa?
Okay, then you look at for a perfect square, because we have to simplify.
Okay, then what did you get when you took the square root of 16?
You said 4,
That's equal to 4,
4,
right? And then you just have what left? Square root of
2.
2, right?
Yes.
So let's just take out the square root of 16 here. And what answer is that?
D as in dog.
D as in dog. So let me take out the square root of 16
Stupid.
here.
Okay, so is answer B?
Yes, answer D. Maureen,
Oh,
what
okay.
did you say, Maureen? Chastity gave me 2 answers. Maureen gave me a different answer. Maureen, you said 16 times square root of 2.
Yeah.
But remember, if you
That's what I
take
said.
factors like Vanessa did, 16 and 2, it's the square root. Square root
Okay.
equals the product of 2 square roots, 16 and 2. 16 has a perfect square root, 4. Remember, I told you to remember those square roots that you know, right? And 16 is one that has a perfect square root. So 16 and 2 are factors of 32. Square root of 16, square root of 2 are factors of square root of 32. All right. Then you take the square root of the 16, which is the 4. Square root of 2 remains in its simplified version because that's a prime number. So we can't factor that in anything other than 2 and 1. Questions on number 3?
No.
Questions? Now you could have put 8 and 4, but then the 8 you would have to make, let's just put here, Maureen. Who said 8 and 4?
Me.
You said 8 and 4?
Yeah.
Well, okay, let's put what you said. Okay, so you say square root of 32 is square root of 8 times the square root of 4. Okay, perfectly fine. But square root of 8 can be factored into what, Chastity?
4.
4 and what?
Uh,
What are 2 factors
4
you
and
can
8.
multiply? No. What are 2 factors you can multiply and get 8? 2 numbers you can multiply and get 8.
4.
4 and what?
2.
Yes, 4 and 2. So that 8, I could put what?
4.
4. I can put 4 here, right? 4, take out 8. And then I could put 2. 2.
Okay, got it now.
But I also have the 4 left. So let's just put the 4 here. So you said 8 and 4, which I said is perfectly fine. 8 also factors into what? 4 and 2. But these 2 have perfect square roots, right? 4 and 4. What's the square root of 4, Chastity?
1.
No. Square root is a number that
Oh,
multiplies
2.
by itself to
2.
give you the number. It's 2. Square root of 4 is 2. Square root of 4 is 2, right? So you have 2 times 2 is 4, and you get the same answer, right? That we got 4 times the square root of 2 right here.
Got it.
Got it? So you can do it like Vanessa did. She started with her biggest number that has a perfect square root. That was the 16. But you could do it like this, 8 and 4, but then the 8 has to be factored into 4 and 2. So now you have perfect square root 4, perfect square root 4, 2 times 2 is 4, and then the square root of 2.
Yes.
Questions? So there's more than one way of doing it, but just remember, this says to simplify. So if you have a radicand, that is a number under the square root symbol, then you have to simplify that by putting factors for it. You can't leave this as square root of 8 because it has factors 4 and 2, just as Chastity said.
Got it.
Got it? Any questions on number 3? Alva, you okay?
Yes, I'm listening, Miss Barbara.
All right. Let's go to number 4. Okay. Next page. All right. We have another radical we want to simplify. 2 times the square root of 24. So let's just take this and you tell me what are the factors of square root of 24. Alpha, what are factors? What are 2 numbers you can multiply and get 24?
2 12s.
2 12s. Okay, let's put what you said, okay? Equal, and that's 2. And let me put now you said 2 and 12. So let me put the 2 here and then put your factors for the 12. And let's put the 2. So take the 2 out and put the 2 underneath the radical here. Take the 4 out. Now, Alva, I have what you said. The 2 is a coefficient. It remains. And then you factor the 24 and the 2 and 12, or 12 and 2. Same thing. But 12 has some factors, Alva. Right? What are
Yes.
factors of 12?
You could say 3
Mm-hmm.
and 4.
I can't hear you.
3 and 4.
Okay, so you want to take this and okay, let's put this here, and I'll copy this and put what you just told me, 3 and 4. Okay, so 12 becomes 3 and 4. So let's put 3 and then put 4. And we also had square root of 2, right? So let me put the square root of 2 back. Okay, so you said square root of 12 has square root of 3 and square root of 4. Now, one of these has a perfect square root. Which one, Alva?
I think it's a 4 and 2.
It's 4. What's the square root of 4?
Square root of 4 is 16.
What's the square root of 4?
The square root of 4 is 16.
Square root of 4 is 2. Okay, so let's take the square root of 4 is 2 and put the 2 here, right? So I'll take this, copy it here. All right, now I'll put what Alvin just told me, equal, copy that. And she told me the square root of 4 was 2. So let's just put the 2 here. And I'll put parentheses here so we don't get this confused. Okay, now what does that equal to? 2 times the square root of 3 times 2 times the square root of 2.
Oh, you said two,
Yeah.
two threes is 6, 2 twos are 4.
Well, but this is a square root.
No, we were talking about 12.
Yeah, but you told me square root of 12 was square root of 3 times square root of 4, which is what I put there. Then you said the square root of 4 is 2. So square root of 4, I put a 2. So I have
Okay.
2 times the square root of
I think
3
I'm wrong.
times the square root of 4, which is 2. And then that's times the square root of 2.
But what are the parentheses for?
326, 326.
To show it's a multiplication.
Yeah.
Oh, okay.
Yeah, because sometimes side by side is not so obvious when you have radicals. So this is 2 times the square root of 3 times 2 times the square root of 2.
So you multiply, it's like multiplying everything.
You can't multiply.
Pardon me, Miss
Hint?
Barbara?
No, because remember, you can multiply if the radicands are the same, you can multiply, but this is a square root of 3 and this is a square root of 2. So sometimes you need to think of the numbers you take for your factors that makes your
Okay.
work simpler.
Yeah.
Vanessa, what would you take for square root of 12?
For me, for square root of 12, their
Yeah,
factors are like,
what would
they're
you
like,
take for the square root of 12?
they're like 3, 4, and 6.
3, 4, 6?
Yes. But for the square root of 12, I'll use 4 because 3, 4 is 12.
How you?
I'll use,
You
no.
good?
No,
I
no.
can-
Think of 24.
Mhm.
Think of 2 factors, one of which is a perfect square root.
24. Oh, perfect square root.
Yeah, 2 numbers you can multiply
And
and
get
get
24.
24, and one of the numbers is a perfect square root.
4 and 6.
That's right, 4 and
Right.
6. Okay, so Vanessa's saying 4 and 6. So what this becomes is 2 times square root of 4 times the square root of 6. So this would be a 4. And let me copy this. This would be a 6. Square root of 4 times the square root of 6. So let's just take these extra numbers out and put a 6. Okay, so she factored the square root of 24 into the square root of 4 times the square root of 6, right? Now, what's the square root of 4, Vanessa?
2.
2. So let's just copy this and put the square root of 4, which is 2. And just so you know, we're multiplying here, I'll put parentheses 2 and then take out the square root of 4 because that's a 2. Now, what's your answer, Vanessa?
2 times 2 twos is 4. It's, oh, there it's A.
Yes, that's right, because 2 times 2 is 4, and 4 times the square root of 6. This is equal to 4 times the square root of 6. Equal, and this will be 4, the number 4, times the square root of 6, and that's answer what?
A.
What answer?
A is an apple.
A, answer A. See, that's why it's important to pick numbers, Alva, that have a perfect square root. See, because like you put 12 and 2. Now, 12 doesn't have a perfect square root. It has factors, one of which has a perfect square root, but the other one does not.
Yeah.
Okay. And then you ended up with numbers here that you really can't multiply. You can't multiply the square root of 3 times the square root of 2. You can multiply the square root of 2 times square root of 2.
Yeah.
Radicands have to be the same. So try to remember your perfect square root numbers, because that'll really help you in your factoring.
So number 4 would be A.
Number 4 would be A. Yes. Questions?
No, Miss Barbara.
Okay. So when you pick your numbers now, and I know you know your perfect square roots. You know square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, square root of 36 is 6, square root of 49 is 7. So once you know those perfect square roots, it makes it easier to simplify radicals because you'll pick numbers that have perfect square roots, which give you fewer steps to solve the problem. All right? Okay, let's look at number 5. Okay, Maureen, number 5. Here's the radical, square root of 243. Now your answers have some hints, right? What are 2 factors, Maureen, of square root of 243?
Okay, square root of 243 is,
Are you there?
okay, listen, yeah, I hear ya.
Yeah, what are 2 factors of 243?
Okay,
2 numbers you can multiply and get 243. And think of one that has a perfect square root.
I say that.
okay.
And like I say, there's some hints in your answers. Chastity, do you see the hints in your answers, your choices?
Okay.
I
Two,
I I got answer A.
What answer did you say?
A.
And why did you say A?
I multiply 81 times 3 and it gives me 243.
Yeah, but remember, this is a radical. This is not a radical. So 81 times square root of 3 does not give you square root of 243. You have to multiply radicals by radicals to get radicals. So square root of 243 is equal to what? 2 factors, both of which are radicals. Which 2, Chastity, can you multiply? I mean, you're close, but what 2 factors can you multiply and get 243? And both of these should be radicals because you're saying a product of radicals equal to a radical. So what 2, tell me 2 numbers I can multiply and get 243.
So 1.
Not a 1 now. We're not, because if it's a 1 in a number, you're talking of a prime numbers. So, but we're talking that numbers that are not 1. Now, you said A, 81, and you said square root of 3. And I said
Would
you're
it-
close. So
Would
what
it
2
be C, Miss
factors?
Barbara?
Yes.
Would it be C?
No, it wouldn't be C. And I want to know 2 factors you can multiply, Chastity, and get square root of 243. Now, both of these factors should be square roots. Give me 2 square roots you can multiply and get square root of 243.
So it's 3.
Square root of 3. So let me just put here. That would be square root of 3, right? So let's put that there. And what else? What number multiplies by 3 to give 243? What number? That means you got to say 243 divided by 3. So what's 243 divided by 3, Chastity?
243.
243 divided by 3. That's your factor. 243 divided by 3. What is that number?
81.
80.
81.
Go ahead, you say it.
81.
What is it,
Mhm.
Chastity?
81, yeah. I was gonna say 81, but I wasn't sure.
Yeah, it's 81. So let's put, now there are your factors. Let's put here the 81. That's why I said the hint was in your answers. So now, Chastity, the factors of square root of 243 or the square root of 3 times the square root of 81. All right. Now, which of these has a perfect square root, Chastity?
3.
That's a
Uh,
prime number. Prime numbers demand
81.
81. What two numbers multiply to give you 81?
Mm.
9.
That's
9,
it.
9.
So this becomes very good. That's a 9. So let's just copy this. Put it here. So this then would be equal to, and I'll just put it here. And this square root of 81 is 9, right? But we put the 9 in the front. Otherwise, you'd have to put it in parentheses. So I'll put this in parentheses and, okay. And this then I'll write as equal to 9 times the square root of 3. And what is that answer? Chastity, what answer is that?
D.
D, that's right. Very good. That's D. You see, you had to have 2 square roots as factors, not just a number and a square root. You have 2 square roots, then we call these the radicands. 3 times 81 gives you the number 243, the radicand underneath the square root. And since 81 is a perfect square root, that means a number times itself gives 81. And Chastity said that was 9. And then we put the answer is D because we put the number. This is a coefficient. The 9 is the coefficient times the radical square root of 3. So there was your hint there, that 81. If they gave you an 81, then 81 is probably one of the factors. So, except it has to be a square root. Then you can take the square root of the 81 and get 9, and you have your answer.
Okay.
Questions number 5.
Can I ask a question, Ms.
Yes,
Barbara?
Alva.
Okay, so I'm just getting the drift of it. It's a 3 and a 9. So, okay, 3 3s is 9 and 9 9 is 81.
But square root of 3 is not 3, is not 3 times 3. 3 times 3 is 3 squared.
Yes,
The square root of 3 is not a whole number.
but you're saying you put the 3 under the radical?
Yes, when, okay, Alva, let's see. If I said 243 and I ask you to give me the factors, right? And the highest factors would be 3 times 81, right?
Yes,
In other words, 3 times 81 gives me 243.
240.
3 times
Mhm.
1 is 3. 3 times 8 is 24. You follow me, Alva?
yes,
Okay. Now, if I said the square root of 243, let's just put that. I'm factoring this, but this factors into square roots. So this would be equal, and then I would have to put 3, square root of 3, and times the square root of 81. The only
yes,
difference is that when I have radicals, my factors have to be radicals too.
Yes.
You follow, Alva?
Yes.
243 factors 3 times 81.
Yes.
Square root of 243 has to be square root of 3 times square root of 81.
Yes.
Okay.
Okay.
And then once you do this, then you know the square root of 81 is 9. So it would be 9 times square root of 3. You follow?
Yes.
Okay. Alba, let me give you this one, 64. What are some factors of 64, Alba? Two numbers you can multiply and get 64. Oh, no, I didn't want to give you that one. No, we can do it. Okay. So 64, what are the factors?
6 and 4, 6, 6.
Two numbers you can multiply and get 64. Alva?
I'm thinking, Miss Barbara.
Yeah, two numbers you can multiply and get 64.
8, 8. No.
8, 8, right?
Yeah.
So
Yes,
that's
I'm
8
doubtful. Yes. 8 multiplied by 8.
times 8,
Yeah.
right?
Yes.
Now, if I made this square root of 64,
Mhm.
let's see. Let's copy this and put the 64. Okay. Now I said, what are the factors of the square root of 64? So let's just make this 64. What would they be, Alva?
It would be 8.
8, square root of 8, because the square root factors have to be square root. So it will be square root of 8 times what, Alva?
8 times.
The square root 8 would be times what square root?
Okay, 8 times 8 is 64.
Alva?
Yes, I'm here, Miss Barbara. I'm
Square root of
just trying.
6, square root, you told me the factors of 64 are 8 and 8.
Yes.
Square root of 64 is what? Square root of 8 times what?
8 times. Oh, I don't understand that one.
No, it would be
I
square
know,
root of,
I know the times is 8 times 8.
yes, but then
So you're saying to factor it out, it would be,
it would be square root of 8 times square root of 8.
yes.
The only difference is this one does not have radicals and this one does, but it's the
Yes.
same factors.
Okay.
All right. This is
Yeah.
one that has a perfect square root. So square root of 64, square root of 8 times square root of 8.
8.
But one thing I should tell you, when you have a square root, you're really raising it to the 1/2 power.
Yes.
So what's a 1/2 plus a 1/2, Alba?
4.
1/2 plus 1/2.
1/2 plus 1/2, it would be 8.
1/2 plus 1/2.
It would be-
1.
1.
Yes.
1/2 plus 1/2 is 1. So
Yes.
8 to the 1/2 times 8 to the 1/2, this would give you 8, which we know the square root of 64 is 8, right?
Okay.
Yeah, because square root is 8 raised to the 1/2 power.
Okay.
You follow? In other words, when I say 8 to the 1/2 power, let me just do this. And let's put 1. Okay, that's raised to the 1/2 power. And if I add 1/2 plus 1/2, I get 8 to the 1 power, which is just 8.
Mhm.
Okay. So if we've been factoring numbers before, but now we're factoring radicals, same kind of factoring, except now you have radicals.
What are radicals?
The radical is just a square root sign, Chastity. The radical is
Okay.
just a square root sign, that's all. and underneath the radical, well, they sometimes use radical to refer to an expression that has a radical and numbers. But if you break it down, the radical is really the square root sign, and underneath the radical is the radicand. All right. Questions number 5. Okay. Number 6. Number 6.
Please write the following
Vanessa,
radical.
number 6.
Yes, Miss Barbara.
Okay, what would you use
For
for your
six.
factors for number 6?
We look for a perfect square. That's the
Look for
first
a
thing you do.
perfect square root of your factors. Now you're taking square root of 96 and you factor in that into two factors, one of which has a perfect square root. What would you use, Vanessa?
4 and 6.
What's 4 times 6?
4 times 6. 4 6 is
16.
4 6 is 24.
What?
4 times 6 is 24.
But we need two numbers multiplied to give you 96.
16 and
So
6.
4
16.
4.
What did you say,
4 4.
Chastity?
16 and 6.
16 and 6, because
Six.
16 has a perfect square
Square.
root,
Square root.
right?
Yes.
So Chastity said 16. Let's put 16
16 and 6.
and 6.
6.
Right? Okay.
Yes.
So this will be 16 and 6. Now, what's the square root of 16, Chastity?
4.
4. So you see your answer then, right?
Mm-hmm.
Yes.
Yeah.
The answer.
A.
See, that's
They.
right.
No.
Very good. Okay.
That's so bright, Miss Barbara.
This is really good. Okay. Square root of 16 is 4. So that would be what? Equal 4. And then just put our square root of 6 behind it. And that would match our C answer.
C. Yes.
C.
C.
Mhm.
That's a 4, not a 2. Somebody said B.
Oh, 4 4 is 16.
Okay, so
16 4 is
answer-
96.
Okay, so our answer would be
C.
4 times square root of 6, which would be C.
Mhm.
Everybody with me?
Yeah.
Yes, Miss Barbara.
Yeah, it's just it's a little bit complicated, but I'm just following the same rules as the previous um uh
Radical.
yeah.
Yeah, well, that's good. But one thing, it helps you to learn the perfect square roots. So you look for the perfect square root factor, and that gives you fewer steps to solve it, right? And you could have taken some other numbers, but then you would have had to break them into factors. That's why I'm trying to help you remember the perfect square root. So when you think about simplifying, you think of the numbers that have the perfect square roots. That
And
means you do it in fewer steps.
factors is well, you multiply two numbers and give you the answer, right?
Yes, factors are
Factors.
just really numbers multiplied to give you what you're looking for. So you say, what are factors of 12? 4 and 3, 6 and 2. All right, two
Yeah.
numbers. In some cases, it may be 3 numbers multiplied to give you a number. Here, we're just working with 2 numbers. So when you think of those 2 numbers, all I'm saying is think of the ones that give you a perfect square root.
Okay.
Okay, that simplifies your steps. All right.
Yeah.
Okay, Maureen, number 7.
Okay.
Let me put it on the next page. Number 7, Maureen.
Okay, the square root of 64.
What two numbers multiply to give you 54?
6 and 9.
Okay, so Maureen says 6 and 9. That means you take the square root of 54 and you put the factors 6 and 9. So this would be equal to, and let's put square root of 9, and that has a perfect square root. Very good, Maureen. Okay, and you said 6. Now, Maureen, what's the square root of 9?
3.
3. So this would be what? Square root of 9 times square root of 6. Let's put that here. And you just told me the square root of 9 is 3. So that's 3. And the square root of 6 does not have a perfect square root. So this would be 3 times the square root of 6. What answer is that? What's the answer, Maureen?
Oh, 3 times the square root of 6.
A.
And
Yeah, A.
18.
A.
A.
So the answer is A. Okay. See, so you see, when you pick the number that has a perfect square root, you only have just the one step to get the square root of that number. Square root of 9 is 3, and 3 times square root of 6. Now remember, this 3 in front of the square root of 6 is a coefficient. So when you have the same radical, and with the radicand, you can add the coefficients, which we're going to get to in the next step, the next problem.
Okay, I said on A, but can I answer B, D also as 18 or no?
Can it, for number 7?
No? Yeah.
Well, how are you getting B?
No, I'm saying my answer is A, but I was just thinking if 3 times 6 is 18, can the answer also be D as just 18? No, right?
No, but square root of 54 is not 18 though, Chastity.
Okay. Okay, I got it
You're
now.
saying the number multiplied by itself to give you 54. 18 by 18 does not give you 54.
Okay, so D would be a wrong answer. Got
That's
it.
correct. That's correct. Just think about what you're saying now. Remember, the square root of a number is a number multiplied by itself to give you the number. 18 by itself does not give you 54.
Got it.
Got it?
Yes.
Okay. You could say 18 times 3 is a factor, but
Yes.
then you'd have to break 18 up into 9 and 2. You'd get the same answer, but it'd just be more steps.
Yes.
Okay.
Okay, got it.
Questions? Number 7. All right. Let's go to number 8. Alva, number 8. Remember I said you could add the coefficients when the radicals are the same. Okay. So coefficient is the number in front of the radical. So Alva, simplify these. Add your coefficients for the ones with the same radicand.
Where are you, Miss Barbara? On
Number 8.
Yes.
I'm on the, okay. So tell me what answer you get. 2 is a coefficient, 4 is a coefficient, 5 is a coefficient, 3 is a coefficient. You can add the coefficients for the same radical. So that means square root of 2, square root of 2, same. Square root of 5, square root of 5 is the same. So Alva, what would be your answer?
Seven.
Would it be C?
You're adding your coefficients. 2 is a
Okay.
coefficient, 4 is a coefficient,
Let's see.
5 is a coefficient, 3 is a coefficient. But you can only add the coefficients with the same radicand. In other words, all the square root of 2's could be added, all of the square root of 5's could be added. So what is your answer?
Okay, so 3 and 4.
Alva?
Yeah, I'm coming, Miss Barbara.
What is
So,
your answer?
okay, so
Add the coefficients with the ones with the same radical, same radical and radicand.
that's two.
So what would be your answer?
I would say it's A.
How are you getting 10?
Is B.
I want to know how Alvin's getting 10.
I had the two.
You added 2 and what? How did you get 10?
Okay, so I have 2, 5. 5 plus 5 and 2 and 2, 4.
But I don't see 5 but one time as a coefficient. Where is your other 5? These are your coefficients. 2, 4, 5, 3.
3.
Those are your coefficients, Alva.
Okay.
And you can only add the coefficients that have the same radicand. So you can only add all the square root of 2's together, and you can add the square root of 5's together. So what do you get? What do you get for the square root of 2's, Alva?
I had all the square root of 2's.
Yeah, add the coefficients.
So 2 and
2 plus
2,
what?
4. 2 plus 4.
No, this is square root of 2.
Yes.
This is square root of 2. Add those
Yeah.
coefficients. What's 2 plus 5?
That's 7.
That's 7. So that's going to be
Yes.
7 times the square root of 2. Now,
Yeah.
look at your square root of 5's. That's a 4 coefficient
Yeah.
plus the 3 here. What's 4 plus 3?
7.
So what is your answer?
D. Would it be D?
No, there's no square root of 4. You have a square root of 2. Okay, let me just.
Can you raise up the page for a little bit, please?
Okay, let me bring it up.
Thank you.
And then I'll put it.
Just a little bit.
Let's see.
No, down. I mean, raise it up a little bit so I can see number 9. All right, right there. Thank
There
you.
we go.
Number 8,
All right.
she's doing.
Now, Alva, what you're doing, let me just simplify this. We've taken the 2 times the square root of 2.
That's 4.
Okay. No, that's not 4. You can't add. This is a multiplication.
Oh, 2 times 2?
Okay. Now we're adding that to this 5 times the square root of 2, right? So let's just take that. So what I'm asking you to do is to add this. Okay. Now this is an add. So I'll put a line underneath it. Okay. And you adding the coefficients, Alva, right? So 5 plus 2 is what, Alva?
7.
7. So this is going to be 7. Put here. That's going to be 7 times square root of 2. Got it?
Yes.
Okay, because you're adding the coefficients, correct? Okay, so you can only add the coefficients for the ones with the same radicals. So you have 2 times square root of 2 plus 5 times square root of 2. This is a plus. You're adding, right? Bring that over somewhere. So it lines up. 5 plus 2 is 7 times square root of 2. Now go to your square root of 5. You have 4 times square root of 5 plus 3 times square root of 5. Alvin, what's that equal to?
You say go to your 5s?
The square root of 5. You have a 4 times the square root of 5 right here.
Yeah.
Add that to 3 times square root of 5. What does that give you, Alva?
25, 25.
No, you're
Good.
adding the coefficient. Let's see, let's just take this, okay. 4 times the square root of 5. That here,
This is 4.
here. Okay, now I have 3 times the square root of 5. Let me take that and put it here. And you're adding the coefficients, not the radicals. You're only touching the coefficients. Okay,
Okay.
now when you add this, Alva, let me underline. What's that equal to, Alva?
2.
4 and 3, 7.
That's right. That would be 7. 7 times what?
7 times 5.
No, square root of 5. That doesn't change. That would still be square root of 5.
Oh, square root of
7
5.
times the square root of 5, right?
Yes.
So when you add these up, you get 7 times the square root of 2 plus 7 times the square root of 5. Which answer is that? A, B, C, or D?
B.
Which one?
Isn't it B?
Yes, very good. It's B.
Yes.
Yeah.
Yeah.
But remember now, you're not touching the radicals or the radicands. You are only adding the coefficients. 4 plus
Yes.
3 is 7. 5 plus 2 is 7.
Okay.
Any questions on the coefficients of radicals? That's just a number in front of the radical. We've been talking about coefficients, but we weren't referring to radicals, but it's just a number in front of the radicals.
Oh, so you do not touch the radicand.
No,
You
don't
just-
touch the radicals. The only time you can do this is when the
That's
radicals
what
are the
is getting
same.
me confused, Miss Barbara.
Oh, you just add the
Oh, the
coefficient.
radicals
Yes,
have
just
to be
add
the
the
same,
coefficient.
Alva. You
Yes.
can't add and subtract these unless the radicals are the same.
Okay.
So you can only do it 2 times square root of 2 plus 5 times square root of 2, because they are the same. Square root of 2, square root of 2. Here, 4 times square root of 5 plus 3 times square root of 5. Then you can add those up. 4 plus 3 is 7. Alva, is it making sense?
Yes, I heard you, Miss Barbara.
Okay, so you can add these radicals. You can add them when the coefficients, when the radicand are the same, you can add the coefficients. You don't do anything with the radicals. They just remain the same.
Okay.
Okay. It's just like if you say 3x plus 5x, you get 8x, right? So 2 times square root of 2 plus 5 times square root of 2 gives 7 times the square root of 2. All right.
Mm-hmm.
Questions? Okay, so that was number 8. Let's go to number 9. Now this one, I want you to try it. Now you have to simplify each one of these one at a time. Okay. So simplify the square root of 27, simplify the square root of 20, simplify the square root of 12, and simplify the square root of 45. Once you simplify these, then you'll have coefficients and radicals, and you can combine them. So start with this one. Just put here square root of 27. So you're going to simplify that one, right? That's equal to something. Then you're going to take this 20, square root of 20. Okay. And then you're going to do the 12, square root of 12.
Mm-hmm.
I need you to simplify each one of those.
Mm-hmm.
Okay, and then the 45. But when you're simplifying, think of the ones that have the perfect square root as their factors. All right.
Can I do the first one?
Okay, tell me the first one, Alva. Good.
Okay, so it would be 9.
Okay, square root of 9, right?
Yeah,
Okay, so that one would be square root of 9. So let's put a 9 times whatever.
excuse me.
Time what? What's the other factor?
That I could get from 27.
Yes, 9 times what?
3.
3 times 3.
Yeah, 9
3
times
9.
3, all right?
Yes,
So,
yes,
so this would be a 3,
yes.
all right? And what's the square root of 9, Alva?
The square root of 9 is 81.
No, that's the
Oh.
square,
No,
3.
excuse me.
the square root,
The square root of 9, 3.
3. Okay, so that would be 3. And that would be square root of 3. So we got the first one. Anybody want to do the square root of 20?
I am.
Vanessa?
Yes, Miss Barbara.
Oh, you want to do square root of 20?
Yes.
Okay, what is that?
Okay, the square root of 20. 2 factors is 5 and 4.
That's right. It's 5 and 4. So that's going to be what? Square root of 4 times the square root of 5. And what's the square root of 4, Vanessa?
2.
Can we put it as square root of 5 first and then the 4, or does it matter?
It doesn't matter. The thing is, the reason I did it this way, Chastity, because remember that one that has a perfect square root is going to be the coefficient. So I
Okay.
put it first, right? I mean, you could put square root of 5 times square root of 4, then I'd have to do the parentheses.
All right.
Where I
Got
can
it.
just put the square root in front of it and then take the square root and put that in front of the square root of 5. Vanessa, what's the square root of 4?
2.
2. Okay. And that would be the square root of 5.
Yes.
Okay, so we got that one. Anybody want to do the next one?
Square root of 4 and 3.
Maureen, square root of 12.
4 and 3.
4 and 3. Okay, so we'll have.
We go right to it.
All right. Okay, square root of 4 times the square root of 3. And what's the square root of 4?
2. 2.
2.
Mm.
So that would be 2 times what? The square root of 3. All right. Who would like to do the 45? Chastity, you want to do the 45?
24,
Mm.
5.
Two
Hold on.
numbers multiply to give 45. One of perfect square root.
5 and 5.
5 times
Right?
5 is 25.
9.
5
9.
times what number? 9. That's right. So this would be square root of 9
5.
times the square root of 5. Okay, and what's the square root of 9, Chastity?
3.
3. Very good. Okay. And this would be square root of 5. Now you've got all your numbers, got all your factors. Take these, plug them in up here. 3 times square root of 3 plus 2 times square root of 5 minus 2 times square root of 3 plus 3 times square root of 5. So how would that look? Take 3 times square root of 3. That's the square root of 27. So let's just put that here. Plus the square root of 20. So that would be plus square root of 20 is 2 times square root of 5. So let's just put that there. So we've already broken this into factors. So this would be, and minus square root of 12, which is 2 times the square root of 3. So let's just put that there. minus, and plus square root of 45 is 3 times the square root of 5.
Minus.
That would be plus. Okay. Let me make this. Plus. These plus signs are too small.
Okay.
Okay, this is a plus. Now, combine these. What is your answer?
One moment.
So we, what do we do
Combine
with
your coefficients. What do you get, Chastity?
5?
Mhm.
5, right?
Minus.
No, you've got a square root of 3 here, and you have a square root of 3 here. You have a square root of 5 here. You have a
Oh,
square root of 5. So combine your square root of 3's, combine your square root of 5's, and what do you get?
3 and 5.
3 times the square root of 3 minus 2 times the square root of 3. What does that give you, Chastity?
that's 1.
That's 1. So you just get what?
1
Square root of 3.
square root of 3.
1, yeah, 1. Well, let's just put it here, 1, or you could just leave it as square root of 3. So let's just put that there. That would be, we'll put the 1 here, because 3 minus 2 is 1. So that would be a 1, right? What do you get for the square root of 5 when you add a 2 times square root of 5 plus a 3 times the square root of 5? What do you get, Chastity?
5.
Yeah, you get 5. 3 plus 2 is 5. So that would be plus, that would be 3 plus 2. So that would be, let me just copy that and put the 5 there. So that would be 5 times the square root of 5. What answer is that? What
That's
answer?
answer D.
Answer D. Very good, because 1 times square root of 3 is square root of 3. So answer D. Okay. So that was one you had to do in steps. You had to simplify each radicand here, and then you had to combine them. This result plus this one minus these two. Okay. Questions on number 9?
Sure. Yes, I do have.
Yes, Vanessa.
Miss Barbara, so we are adding or subtracting the coefficient. The
Yes,
same.
it's always the coefficient, Vanessa. What you did, you simplified each of the radicals, and notice they all have coefficients, right? Then you plug back in what they are. See, look at this. What we got for the simplification, we plugged in the square root of 27, 3 times square root of 3, plus square root of 20, 2 times square root of 2 times square root of 5, minus square root of 12, which is 2 times square root of 3, right here, plus square root of 45, which simplified to 3 times the square root of 5. Now, at this point, you only have to combine coefficients. Nothing
So,
to the radicals, right?
okay,
You've already found your
correct.
radicals.
Okay, so if like how we have 3 times 3,
3 times square root of 3.
3 times square root of 3. So we combine 3 times square root of 3 with 3 times square root of 5.
No. You can only combine like radicands. So you can only combine this 3 times square root of 3 with the minus 2 times square root of 3.
Oh,
That's why you have 3 minus 2, and Chastity said 1,
1.
which is
Okay.
the same as square root of 3, right?
Okay.
because normally the 1 is understood, you have to put it, but I put it here to show that when you take 3 minus the 2 coefficient, you get a 1.
Yes.
Then you look at your square root of 5s. You have 2 times square root of 5, and you have 3 times square root of 5, and a 2 plus a 3 gives you a 5.
Okay, I
Got
understand.
it?
Yes, Ms. Barber, thank you.
Okay, so you're combining coefficients, whether they're addition or subtraction. And just like you did when we were looking at the variables, like 2a minus 3a plus 4c minus 5c, you're still looking at coefficients, except now the coefficients are in front of radicals.
Okay.
So over here, do we still do the like the positive and minus, positive, negative, and it's negative,
Yeah, you
or
still, the sign rules still hold.
okay, the sign rules.
The sign rules hold, whether you're using radicals or variables or numbers, it's still plus, minus, you subtract.
Okay,
Plus, plus, you
thank you.
add. Minus, minus, you add. Okay, when you get to, if you're multiplying, minus, minus gives plus, plus, plus gives plus. Division, minus over minus is plus, plus over plus is plus. Like signs, plus, unlike negative. Questions on number 9? Okay, let's look at number 10. Now, number 10 is an area problem. Everybody remember the formula for finding area of a rectangle?
This area, length,
Alva, what's the area of a rectangle?
plus, is
Alva,
length plus and width.
Yes, Ms. Barbara.
what's the formula for area of a rectangle?
The formula.
Yes,
Okay.
area of rectangle equals what?
Area, width,
It's
and
equal to
length.
what? Area of rectangle equals what?
Width and length.
What operation?
Maybe not. They have been multiplied.
What operation? You just say length and width. Now, here's a rectangle. There's the length, there's the
Yes.
width.
Yeah.
What do we do to get the area? What operation, Alva?
You'd have to multiply.
That's right, multiply.
Yes.
Length
Times width.
times width, which means you always get square units, right?
Yes.
So now what I want you to do, I want you to find the area of this rectangle, and you're given your dimensions as radicals. So you're going to multiply the length times the width. So what this will look like, let's just put A equal. Now let's just put the length. Take this number and put the length. Okay, so this would be this. Put the length here. We're gonna have to put this in parentheses. Okay. Now that would be times the width. And the width is this number, right? So this would be parentheses and close parentheses. All right, so this is what we want to multiply. Multiply 2 times square root of 3 times square root of 3, and then 2 times square root of 3 times 2 times square root of 6.
So therefore,
I
if
got
we
mixed right there.
multiply, we're doing distributive properties.
Yes, because you're multiplying this radical by this radical and also by this radical. So let me write how it would look. Okay, let me just, and and then I want you to multiply it. But remember, when you multiply the radical by the same radical, you get 1. Because I said a radical is raised to the 1/2 power, right? So this becomes square root of 3 plus 2 times the square root of 6 times 2 times the square root of 3. So this will be 3 times this. Okay, let's put that here. I'm just breaking it down. Okay. 3 square root of 3 times 2 times square root of 3. So it's square root of 3 times this radical and also this times this. So this will be plus. I'm breaking it down for you to okay. So this would be plus parentheses. So this is like saying A plus B times C. C is multiplied by A and C is multiplied by B. So square root of 3 is multiplied by 2 times square root of 3, and 2 times square root of 6 is also multiplied by 2 times square root of 3.
Okay.
All right. So multiply that out. Tell me what you get.
Okay.
Remember, I said square root of 3 times square root of 3 is 1/2 plus 1/2. So that means square root of 3 times square root of 3 is 3. And
Yes.
then 3 times 2 is what?
6.
6. Square root of 3 times square root of 3 is 3. A square root times a square root of itself is just the number.
Yes.
This is 1/2 plus 1/2 is 1. So that's 3 times 2. So this first one, let's just put this here. A. So that first one, you'll get 6. Now do the next one.
Okay.
Now remember, the square root of 6, you can break that down into square root of 3 times square root of 2. Okay, because that's not factored as far as it can be factored.
So
Anybody get the answer on the right side?
that is yes.
This in front of the plus is just a 6. So you have 2 times the square root of 6.
We get
Let me just,
um
and I'll just put a plus and then just factor that for you. Okay, so let me just take this and factor the square root of 6, the square root of 3 times square root of 2.
we have 3.
So let me just put this here.
Yeah.
Now, the square root of 6, let's make that that's square root of 6 times square root of 3 times square root of 2. So let's see. Square root of 6 times square root of 2.
Wow.
I'm just factoring the 6. Factoring the 6 and the 3 and the 2. So that's 3 and 2. That's in the square root of 6. And what we have left is 2 times the square root of 3. So
Over here.
does anybody see the answer?
Okay, let's say the first half of distributive properties is 3 times 2 is 6, right?
Which one are you looking at right here?
Yes, I'm doing from the beginning of it, the start of,
Are you right here?
yes, so
Yes.
3 times 2 is 6, right? And then 3 into 3 is 1.
No, you can't, but these are radicals, Vanessa. So the square root of 3 plus 2 times square root of 6 multiplied by 2 times square root of 3. Now, that means this 2 times square root of 3 has to be multiplied by this expression and also by this expression.
How come we can multiply by square root of 3 times two square root of 6 first? What does that
No,
jump
because
from
you
the
can't
3?
multiply unless they're the same
Oh, okay.
radical. I can't say
Okay.
6 times 3 is 18. The 6 has to be broken down where it has a square root of 3. Then I can multiply it.
All right.
Okay, so that's why I said square root of 3 times 2 times square root of 3. That takes care of this part. Plus 2 times the square root of 6 times the same expression, right? But I had to take the 6, the square root of 6, and break it down into square root of 3 times the square root of 2, right here. Okay, because that wasn't simplified. 6 can be broken down into factors 3 and 2. So square root of 6 can be broken down into square root of 3 and the square root of 2. Now, what do I get when I multiply this out, Vanessa? What do I get?
Where do you get the after the 6 plus and the parentheses? How do you get the 2, the 3, and the 2?
Oh, okay. So this, okay, I have my 6, right? That's from here.
Yes.
That's a 3 times 2 is 6. Okay. 2 times square root of 6 times, you mean right here, right? How did I go from here to the next step? Okay, square root of 6 are factors 3 and 2. That's how I got this 3 and 2. Follow?
Yeah.
I just factored the square root of 6 and the square root of 3 times square root of 2. Everybody
Okay.
follow me there?
Yeah.
Okay, so to go from square root of 6, I went to factors square root of 3 times square root of 2.
Okay. And the 2 in the front by the parentheses.
Well, that 2,
That
that's the 2 we had right here. That's the same 2.
or
This
we
2
just
right
copy it.
here is the same 2 that I have here.
Okay.
2. I just took the square root of 6 and simplified it to square root of 3 times square root of 2, right here.
Okay.
Everybody follow me there? I just broke that
Yes.
down into 2 other factors, all right? Now, what is this equal to? Anybody want to tell me? What is that equal to? Square root of 3 times square root of 3 is 3, right?
Yes.
And what's 3 times 2?
6.
And what's 6 times 2?
12.
And then I have square root of 2 left. So that means this becomes,
Wait.
copy, we'll go through it to make sure you understand. So this becomes, like I said, square root of 3 times square root of 3 is just 3. 3 times 2 is 6. 6 times this 2 is 12, but I have a square root of 2 left. So this becomes 12 times the square root of 2.
So it's B.
It's B. That's correct.
Okay.
Okay. Does everybody understand how I went from here to here? because I can break it down. Okay, let me just take this and copy it on the next page and show you how I went to 12.
I just put it at the bottom from it.
Well, it's gonna flip to the next side.
Oh,
Yeah, okay,
Mhm.
so let me just take it in steps. Square root of 3, and I'll put this here, okay, and put square root of 3, and that's equal 3, right? When I say square root of a radical times itself as a radical, it's just a number because it's like 3 to the 1/2 plus 3 to 1/2 gives you 3 to the 1. Okay, so that would take care of the square root of 3 and the square root of 3. Okay, so this would then be, let's just take this, copy it, and put, okay, now instead of having the square root of 3 times square root of 3, I said that's 3. So I can take the square root of 3 out, right? Take that out. And I said square root of 3 times square root of 3 is 3. So that would be 3, 3. Okay, everybody with me? Now, what's 3 times 2?
That's
6,
6, and 6 times 2?
12.
12. So this would then be, and this is added. I just put the plus in front of it. So that would be plus, and I have a 12, and then times the square root of 2. The square root of 2 is still here, right here. Okay. And that would be 12 times square root of 2. And I added that to my 6, right? That I got in that first half of it.
Mhm.
Any questions on how I got the 12? Questions?
Yes, I figured it out, Miss Barbara.
Alva,
Yes, I figured it out.
you figured it
So
out?
you say
Okay,
3 times 2 is 6,
right.
and 2 sixes is 12.
That's it. Very good.
Yes.
Because the square root of 3 times square root of 3 is just a 3. That's my
Yes.
3 right there, right?
Yeah.
But up here I had a 2, and then I had another 2. So I have 2 times 2 times 3 is 12, and then my square root of 2 is left because that's a prime number. I can't simplify that anymore. Questions? Number 10.
Yeah, I figured it out. So it
Good.
would be now B.
So the answer would be 6 plus 12 times the square root of 2. So answer B. Yeah, problem like this is testing you whether you remember from your geometry the area formula for rectangle, and then solving it by multiplying length by width, where the length and the width are not just straightforward units, but they are radicals. Okay. All right, let's go to our algebra worksheet. Go to a new share. And let's go to our worksheet. Okay. We're doing number 8, but I think I wanted to go through, well, we stopped, I think, at 40, but I think, Alva, you sent me something
Yes.
and I wanted to go through. Okay. 36 you had right, Alva? 36
Yeah, and 37.
and 37. Okay,
Yeah.
so let's look at 38. So 38. Okay.
What I did, Miss Barbara, I had up all the numbers
Okay.
And
And you
and
divided by 11, right?
I divided by 11, but
what did you get?
I meant to pick C.
But Alva, what did you get when you added up all the numbers and divided by 11? Did you
I
get
get
80?
898, something
And
like
then you
that.
divided by 11, and the mean was 82,
Careful.
Yes,
right?
the mean was 80. Yeah,
The
because the mean,
median is the one in the middle, and since it's 11, there's just one number in the middle, and that's the 81, right?
yes, 81.
So the median, you got 81. What's your mode, Alva?
My mode was 76.
76, right?
Yes,
Now,
yes.
when you compare these, the mean greater than the mode.
But I think I put the wrong answer there.
Well, the mean is greater than the mode. It's 82 versus the mode is what?
76.
76?
Yeah.
So what answer did you put?
I put let me
I can't hear you.
I am looking for it, Miss Barbara. I have it.
Yeah, you didn't put that one. You got the right answers for your mean, mode, and median. You just have to do the comparison. The mean is 82. The mode is 76. It's greater, so that's answer A. It's not mean less than median, because mean is 82. The median is 81. The mean is greater than the median. The mode is not greater than the median because the mode is 76 and the median is 81. It's less. And of course,
So
they're not equal.
it's A.
It's A, answer A.
Okay.
So you just wrote the wrong answer.
Yes, I put instead of A, I put instead of A, I think I put C.
Oh, okay. No,
Yes.
the mode is 76, so that's not greater than the median of 81.
Yes, because the
Okay,
median
so you
is
just made a
81.
mistake in comparison, but you figured everything out. Okay.
Yes, but I know the mode is when you have the numbers that appears the most.
That's right. All right. So you understand what they are and you calculated them all correctly. But somehow when you did your comparison, you made a mistake. Okay.
Yes. Okay.
Now what happened on number 39?
Number 39. Just a minute.
Have a Halloween party, 80 children. Each one get at least one candy bar. That means a greater than or equal, right?
It was 80 children.
Okay.
And one got a candy bar.
Okay.
One each. So I know it's a division. So I think I give you C, but it's not C. I think it's B.
If each child should get at least one candy bar.
Yes.
That means 18 candy bars times the bags has to be greater than or equal to 80.
Yes.
At least means greater than or equal, right?
Yes.
So that means it has to be A. When you multiply 18 times the number of candy bars, what you should get should be greater than or equal to 80. So that each child would get at least one candy bar.
Yeah, I didn't pick A. I think I picked
okay. So that would be the answer for that one. Just remember this at least means greater than or equal.
Okay.
Okay. So if you have 80 children, you need 80 or more candy bars. That's a greater than or equal.
Yeah.
Miss Barbara, I'm stepping out for like 3 minutes, okay?
Yeah, okay. All right. So that's a greater than or equal, okay? For number 39.
Miss Barbara. Yeah.
All right, let's go to number 40. I think that's where we stopped in the Monday class. Oh no, we didn't. We did 40.
Did we did 40?
Well, we did 40 on the Monday class.
Yeah, but I didn't do it.
Okay,
But I do it
okay,
on my
let's,
own.
Maureen, go
I
through
did
40
it
for
this
Alva.
morning.
Alva, listen to Maureen. She's gonna explain 40 to you.
I think I did it for myself.
You did it? What
Yes.
answer did you get?
A.
Okay, all right, so you're okay with number 40.
Yeah, you okay. Yeah.
Okay,
Yeah.
all right, so we're okay with 40. Let's go to 41, Maureen. How do you do 41? Did you do
41?
41? I think that was where we stopped.
Yeah, 41. I do a lot of writing, but I can give you the answer.
No? Vanessa, did you do 41?
I was doing it for myself. I don't know if I got the answer right. I picked C.
What did you get?
C.
Well, it's not C.
The answer is B.
Oh, okay.
The
Because
answer
it's
is B.
saying,
How did you get that, Maureen?
Or because I do it like let B, like let M and B be the price after 3 years. Then I take the 20,000, right? And I put 1.05 over 100, right? I do it along with it. Then I get 0 minus 0, a minus, always call it a dash 88. And then I think I multiply the 20,000 by 0.68. I think that's what I do. I'm sure.
Now, you have a depreciation.
okay. Well, why would I do it, Miss Barbara? It's 20,000 decrease in 3 years. So when I check how much is 12% of 20, I get 12,000.
Okay. Well, first you need a depreciation factor, and it's going to be 100% minus the 88. 0. Okay, that's 12%, and we convert that to a decimal.
Yeah.
Okay, so the 100% is what he paid for the car?
Yeah, and then it depreciated. So we call that a depreciation factor. Then what we have to do is take the 20,000 times this is an exponential problem, times the 0.88. Well, actually it's,
How you get the 88?
how did I get 88?
Take the extra from 100.
Well, it's 12%. So 100 minus 88 is 12%.
Okay.
So it depreciated by a factor of 0.12. I'm sorry, I'm doing it the reverse. It should be, this should be 12. And this would be 88. And 0.88. Depreciation factor is 88. So it depreciated by 0.88. It went down in value. That's what depreciation, right? But the way we find how much it went down, we take the 20,000 and multiply it by the 0.88 raised to the value of the car after the period. So
okay, is this, excuse me, is
Yes.
this just a number you came up with? Because I didn't see it in the math,
What?
the 88.
No, they gave
I've
us,
got
it decreases at a rate of 12% a year.
Okay,
And I just subtracted that from 100
okay,
to get the depreciation factor is whatever your rate is subtracted from 100.
okay.
So it depreciated by 0.88 raised to this 20,000 would be times the 0.88 raised to the 3 years power. So
Okay.
that's the number of years. So this would be times 0.88, and we would raise that to the
I would never get that one right.
raise that to the third power,
Yes.
and that's going to be equal to, let's see, I'm going to put that. Okay. And I want to put the number that I got for that, 0.88 to the third power. And that gives you 0.68147. So that would be equal to 20,000 times, and when I did that on the calculator, 0.68147. 0.68147, and that would give you the answer $13,629.44,
Oh, which is
which is
B.
answer B. Okay.
Yeah. That one is a little critical for me.
Yeah, that one's a little involved, but
Yes.
depreciation problems are always exponential factors, okay?
Okay.
You have to raise the depreciation factor to a power representing the number of years you've had, say in this case, the car, 3 years. That's
Okay.
why we have the third power.
Okay.
So we can do this on the calculator. The way you do it on your, those of you with the TI 30 calculator, you can go to your it's really right next to your 7 on the left, and it's the second. So you can put in your number, press that key, and it lets you put in the power, and then that would give you the
Okay, so you press second
yeah, you have to press second. Let me just
and put in the numbers.
okay. So you press second. All right. Then you get a radical.
Yeah.
All right. Then you can put in the number.
Okay.
That's the
So what number would you put in, Miss Barbara?
wait just a minute. Okay, so you put in
Payment of bill.
okay 0.88. Okay, then this, and then the power. No, you put in the 0.88, and you want to raise it to the third power. So you put second, okay, 0.88. Okay, then
Where are we? I don't see. I'm back.
yeah, we're at number 41, where we're trying to find the depreciation, the value of a car after 3 years depreciation. So you first get your depreciation factor. That's the rate at which is depreciating per year, subtracted from 100. That gives you the factor 0.88. Then you multiply the value of the car when you bought it at 20,000 times the depreciation factor 0.88 raised to the
Okay.
power of the
Yes,
number of
yes,
years you've had the car. And that's why we have the 3. And if once you get this and multiply by 20,000, you get the value of the car after 3 years would be 13,629.44. This is an exponential type problem.
Okay.
Depreciation is an exponential type problem.
I'm gonna unmute myself because I'm taking care of my granddaughter, so it's like a little bit of a noise, okay?
Okay, no problem. All right, so Alva, I will send you the steps for doing this on your calculator. All
Okay,
right.
Miss Barbara.
Let
Okay.
me make a note of that. Okay, I'll send you the steps. Okay, so that was 41. And let's go to 42. Vanessa, did you do number 42?
No, Miss Barbara.
Maureen, did you do 42?
I get answer 9, but I don't know if it's right.
What did you do, Maureen? Oh, I can't hear you. Your sound is.
I said I get
Yes, I think I did this. Ben has
Maureen, your
4.
sound is low.
I get A said.
Yeah, but how did you get it? Tell me what you
I know.
put.
I just work. I didn't work out. I just say like Ben has 4 more than twice as many CDs as Jay.
How
Every total.
did you write this
Yeah.
mathematically?
I didn't do nothing in mathematics. I just read it out and do
I
it.
can't hear you, Maureen.
I just read it out and do it.
Yeah, but how did you translate this to the math? Ben has 5 more than twice as many CDs as Jay.
You do.
I don't know. I just figured it out.
But how did you write this as the math?
I didn't write the math this bad. I just read it. I pick an answer.
B is Ben. J equal J. Now, Maureen, tell me how do you write this as Ben has 5 more than twice as many as J? Tell me the math. What is Ben equal to? Ben equal what?
4 more
Maureen?
than twice.
Huh? I want you to translate this expression to the math. How do you write Ben has 4 more than, which is an add, twice as many is a multiplication. Tell me how to write this.
I can tell you this now.
How would you write that, Maureen?
I will write 4.
4 more than, twice as many.
Okay.
How would you write it, Vanessa?
Would you put 4 Ben equal? Am I getting right? Sure.
Ben equals 4 more than, that means added, to
Yes.
twice as many as J. Tell me what to write. Ben equals what?
Ben equal 4 or more.
4 more than twice. How would I write
if you
twice
put
as
4
many
more,
as J?
if you put 4 more, then you put 4 as, let's say, next to 4, you put N.
Now I'm using B and J for Ben and Jake. So how do I write twice as many as Jake? How would I write just that expression?
Right. It has to go close to each other. Let's multiply.
How would I write twice as many as Jake? Twice as many is 2 times, right?
Yeah.
So it would be 2J plus 4.
Okay.
4 more than twice. 2J is twice, 2 times J, plus 4 is 4 more than. Everybody follow?
Yeah.
Twice as many as Jake is 2 times J. 4 more than, add 4 to it, right?
Yes.
Now, if they have a total of 31, that means B plus J equal 31, right?
Yes.
But we know that B is 2J plus 4. So let's just substitute that in for B. So
Oh,
that becomes
okay.
3J plus 4, right? Because now we'll just have the
2J.
one unknown. That's 2J plus 4
Oh,
plus J. This would be,
plus 4.
okay, that would be plus J
J.
equal 31.
Okay, I can do this from here.
Okay, now tell me, Vanessa, what do you get?
Okay.
I would say
What
two.
you do, you because this is J, 2J and J, so you add those 2J's, right?
Right,
So you get 3J's
very good.
plus 4
3J
equals 31.
plus, we still have that 4 equal
Yeah.
31. Then what do you
Then,
do next, Vanessa?
okay, so we subtract 4 on both sides.
All right, very good. Subtract 4 from both sides.
You have
Both
J,
sides, okay. Now let's just do that, and what do you get?
31 subtract 4.
Subtract 4 from both sides, so
So you got
minus 4 on the left,
27.
minus 4 on the right.
Mhm.
Okay. And what do you get on the left?
On the
Vanessa?
left, you have J, 3J remaining.
3J, okay. And what do you get on the right?
So we, because it's multiply, we do the opposite, which is division.
No, 31 minus 4 is what?
31 minus 4 is 27.
27, okay, 27. And then what did you do?
Okay, so you cross out the 4, because you have that. So you have, on the left side, you have 3J left. You bring
Okay.
down the 27.
And how do you solve for J?
So I'm solving for J now. So
Right.
we are, yeah, we're dividing, right?
Yeah, divide, because 3J
Yeah,
is a
we're
multiplication. So
Yes.
divide
So we have to
both
find for J.
sides by 3,
Yes.
right? So then J is equal to what, Vanessa?
3 into 27 is 9.
It's 9, right? And
Oh.
answer, what answer is that?
Mm. Okay.
Like up here, answer, I think that was A.
Yes.
Answer A.
Okay. Oh.
So I want you to translate the words into the math. 4 more than, add that to twice as many. So twice as many as Jake is 2J. 4 more than is add a 4. Now, once you do that, you can substitute the 2J plus 4 in for B, and then you have the one unknown. 2J plus 4 plus J is 31. Then you can solve it, get J equal 9.
Ms. Barbara, where's the 2J come from?
So,
Oh,
It's a
twice
twice.
as many.
what
Twice
Vanessa,
as many
Two
means to
times as
multiply.
many. That's where the 2J, because it says Ben has 4 more than twice as many CDs as Jake. So that means twice as many as Jake is 2J. And then 4 more than means add 4 to that, twice as many. Got it, Chastity?
Yes.
Twice as many, 2 times as many. Twice means 2. 2 times as many as Jake. 4 more than means to add 4. So that expression translates into 2J plus 4 is equal to Ben's number of CDs. Then once I have that J in there, then I can, and we know the total is 31. Ben plus J CDs equal 31. Then for Ben, I can put this 2J plus 4. That's where I put it right here.
Yes.
Plus J is 31. Now I have only one unknown, that's J, and solving for J, we get 9.
Okay.
Questions?
Yeah, I would like to learn a little more about that one.
Alva?
You will send it, you're gonna send it to us, Miss Barbara?
Yes, I'll send
Sent
you the
it. We
session.
have this. This is
Um,
the homework.
Yeah, I'll send you the session.
This-
Now, homework.
Quiz.
We'll continue with this sheet. Now, once we finish this sheet, we're going to functions.
Okay.
All right. So I think this goes to 50. So homework, do 43, 44, 45, and 46.
All right, so 4.
Yes, and then you
Okay.
can continue if you like. It goes up to 50. 43, 44, 45, 46.
All right.
And we'll
okay.
continue with that next time.
Okay.
Any
Miss Barbara.
questions on anything?
No, we are getting there.
Yeah, well, look through your session, the notes that we did on this worksheet. I'll be
Yes.
emailing that. And
Yes.
then since this was recorded, I will be uploading it to YouTube. Okay.
Okay, Miss Barbara.
All
Thank
right.
you.
So long, everybody.
Have a good
Bye-bye.
Okay,
day.
you take care, Miss
All right.
Barbara. You have a good evening.
All right.